Here we go. We're going to look at trig identities. I will mention that this is a highly intense algebra section. Okay, so if you kind of brushed off factoring and all them algebra skills, you may struggle in this section. So just take a deep breath. We're good, right? All right, so let's see what this section's about. So two functions are said to be identically equal if the two functions are equal, right? F of x equals g of x, and for every single value of x for which both functions are defined. An equation that's not an identity is called a conditional equation. In other words, it depends on what value you actually plug in. We have already talked about identities, and hopefully you kind of sort of have these down, where tangent was sine over cosine, cotangent, cosine over sine, or remember cotangent 1 over tangent, that's why that gets flipped. Cosecant 1 over sine, okay, or sine is 1 over cosecant, and you should be able to go either way. Secant 1 over cosine or cosine 1 over secant. And then we talked about these three, the Pythagorean identities, the sine squared plus cosine squared equals 1. In fact, we just solved a trigonometric equation using the tangent squared plus 1 equals secant, and then the cotangent plus 1 equals cosecant squared. Then we talked about the even and odd identities, that everything is odd except the cosine and secant, meaning that the negative comes out front. So in other words, when you input a negative value, your function becomes negative. This one, you input a negative value and your function stays the same. So this is a section that students always say, well, how do you know what to do first? You don't. You just try stuff. And these are things to try, such as multiplying by 1. And you might say, well, that's kind of stupid because when you multiply by 1, you just get the same thing. Well, why? You could say, yeah, but what if you turn 1 into sine divided by sine? And that's what we mean by multiplying by 1, to be able to simplify these expressions. Write trig expressions. Anytime you see fractions more than 1, try to get a least common denominator. Write trig expressions in terms of sine and cosine. This one I tell every single student always, just as soon as you see tangents, cotangents, turn them into sines and cosines to see if there's something you can do. Certainly don't change the final expression though if you're just making it more complicated. If your answer is tangent, leave it as tangent. And then when showing two identities are equal, so that'll be another part in here, always start with the more complicated side. So let's look at an example. Get my pen, get my ink color. And so the very first thing that I said is always turn everything into sines and cosines. So the first thing I see is a cotangent, which is cosine over sine, and then I see cosecant, which is 1 over sine, and as we know with fractions, when you're dividing, you flip and multiply, and doing so cancels that, and this simplifies to just cosine. That roof was scalp. And so, like I mentioned, you always want to first look at this and see, do you see any identities that you could, make this look a little better? And again, go straight to turning everything into sines and cosines. All right, next one. This is an actual show, which means to show that one side looks like the other side. Well, I don't really know anything to do at all by just staring at this, except what I just said. Why not turn everything into the identities? So cosecant's 1 over sine, tangent sine over cosine, and then 1 over cosine, or I could leave it as secant, just whatever I want to do. But you probably can see already that turning that into 1 over cosine, they're equal. That's it. Okay, so these first two examples were really good ones to just change everything into sines and cosines, because then very quickly you can see that we ended up with this left side is secant equals my right side. I will mention usually you don't mess with the side you're trying to get it to look like, but I just showed it in this step so you could see immediately that this is 1 over cosine. All right, let's keep on going. Okay, so what in the world am I going to do here? Everything's already in sines and cosines, so the only thing that kind of catches my eye is I see this 1 minus sine theta, and I'm thinking, well, how can I get that on this side? So what I could do, this is going to be that technique where I'm going to multiply by 1. And once again, how in the world would I have known to do that? Lots of practice. I mean, I know you hate to hear that, but that's how you finally get good at these, is you end up doing the same thing over and over and over. So I'm going to multiply this by 1, but I'm going to call my 1 minus sine theta over 1 minus sine theta. Okay, so I'm not messing with this side because this is the side I'm trying to get my left side to look like. So I multiplied by 1. Now what I'm going to do is I'm going to multiply the bottom out, so that becomes cosine. I'm just going to leave the top alone, 1 minus sine theta. If you are really, really, really good in your algebra class, you know you don't have to FOIL this, right? Because all I have to do is take 1 minus sine squared theta. If you don't remember that, that's what I'm doing, is I'm foiling, okay? But when you have the plus and the minus, you get the squares. Now, this piece right here looks very, very familiar. So let's highlight it. That this, if you remember, there's an identity that sine squared theta plus cosine squared theta equals 1. Well, I can turn that into cosine squared theta equals 1 minus sine squared theta. So where I see 1 minus sine squared theta, now I can simply replace it with cosine. If I can get my purple back. And so once again, I'm not doing anything up top. So cosine theta, 1 minus sine theta. And then the bottom I'm replacing with cosine theta, or cosine squared, I'm sorry. Don't let me make that mistake. Okay, so notice 1 minus sine squared is cosine squared. So now I can cancel one of these on the bottom, and I end up with 1 minus, too many humps there, 1 minus sine, and then just 1 cosine at the bottom. And if you recognize that, that's that one right there. So you are kind of keeping your eye on the prize. I always used to tell students that, I'd call it that. But you kind of are going through the stages of, well, how would I know to multiply by 1? Well, what? I got to try something. And you're going to see when you first start doing these, that's going to be the steps, is just try something. But then with repetition, you'll end up doing the same thing over and over and over and over and over. That's why I give you so many homework problems. You're welcome. On to the next question.